Thanks for coming to this talk. This is distributed platform development with Groovy. This thing is kind of loud. Is it possible to turn it down a little bit?
I'll have to find an AV guy.
Oh, okay. No, it's probably fine. No worries. This is actually kind of a talk about software craftsmanship more than anything. We will talk about how we can make use of Groovy for the purposes of building distributed systems. But I think more than anything, this talk is really about how do you kind of make sense of the sort of modern architecture patterns, the modern architecture styles that are being introduced, and especially the ones that have been talked about during this conference. So to that extent, we'll talk about Groovy in the sense that we're all hopefully Groovy developers. But this idea, and I think probably the majority of what I'm going to be talking about, scales between really any language, Groovy or Java or whatever, right? Whatever it is that you want to do. So we'll basically be talking about the concepts around building a distributed system in a composable architecture, and how we can go about doing that with the tools in the Groovy ecosystem. Like I said, there's been a lot of talk at this conference about microservices and SOA, but there's not really been a great deal of talk about how we can take those and fit them into a modern system architecture, right? So everybody talks about building the microservice, but that's not the hard part. We know that we can do that. That's the easy part. Making sense of those in the broader context is the stuff I'm going to be covering here, and sort of putting what it means to build microservices into perspective for you guys. Okay, so a little bit about me. I write for InfoQ about Java and JVM technologies. I have a few articles on there about microservices. I have one in particular about building microservices with Spring Boot. If you guys are interested in Spring Boot or anything like that, it's probably a good resource. The code for this and all my other talks and all future talks is going to be available on my GitHub, as well as open source work that I do, github.com/dandeveloper. Periodically, I've been known to tweet, and I do that under the @dandeveloper. You can definitely unfollow me. You can follow me first and then unfollow me later. Also, questions or anything about the content that we're covering here, or about content from another talk, reach out to me directly through Gmail, danielpwoods@gmail.com. And specifically, a lot of the stuff that we're going to be talking about has to do with the work that I've been doing at Netflix. Some of the lessons that we've learned probably won't cover too in depth the actual work that I'm doing, but more the conceptual stuff. So, like I said, a lot of this is craftsmanship and how do you take microservices and make sense of them. So it's probably a good idea to start off. The title of this talk is distributed platform development. So what is a platform? And that can basically be described as being a broad set of functionality structured in a common way that exposes one or many business functions. So I used to work in insurance, and in the insurance industry, there's a lot of really good problem domains to solve. So I use it as an example a lot. So if you consider an example of building a distributed system, and you consider an insurance company, I think everyone can kind of understand this. There are very well-defined aspects of that system, and if you think about it in terms of what an insurance company might be hoping to accomplish, maybe you have functionality within the system related to underwriting, maybe you have functionality related to accounting, maybe something for customer service, maybe another vertical for claims management and processing. So these are very well-defined aspects of the system, right? So when we're talking about building a platform, we can effectively take what the business functions are, and we can slice them vertically And in that way, what we're doing in that case is we're able to expose the broader system of an insurance company's computer system into basically a distributed platform, right? By identifying what those business functions are and exposing them. Those verticals, in turn, represent a stack of services that fulfill whatever that business requirement is. So if we think about underwriting, maybe within the underwriting vertical, we have an underwriting rules engine. We have some processing for running rates and ensuring rates are locked, compliance aspects, things like that, right? So all of the component pieces that comprise a specific vertical. This is an important thing to do. I think that this applies to basically any business, any type of system that you're looking to build. You can really look at it, identify what those business functions are, and then those are the verticals that you need to work with for building system functionality. So those top-level concepts, they can be broken down further into more technical and granular verticals for their respective implementations. Like I said, for the underwriting side of things, maybe you have a rules engine, right? And you have compliance and rate locks and stuff like that, and risk analysis, right? And all of this stuff is designed to satisfy the goal of underwriting. So that's what understanding those slices is all about. So you understand their top-level business goal, and then you can break it down into the technical aspects of it. And what we're talking about doing here is we're talking about designing a pattern for architecting a system, right? And this forces us to think about modularity of the system in terms of the business function, which means that the system's technical requirements and implementations are allowed to expand and contract as the business needs evolve, right? So we don't get locked in a situation where the system is holding the company back. Instead, as the business grows and as the needs change, the system can kind of evolve with it because we've separated these aspects out. This means that also that there's a very clear separation of responsibility at the service tier, and that allows those technical implementations to evolve independently. So by not coupling the technical implementations within the verticals of the system, they're able to kind of grow as they need to. And that means a lot of different things. That can mean a framework can change. Maybe we need to or want to bring a library in, for example, into a particular application. As long as we don't have those cross dependencies within the technical implementations of the vertical, then they can do whatever they need, right? So that's a good value proposition, I think. One of the attributes of the service implementations within those verticals is that they are, this is effectively distributed computing, and they can maintain their own data sets, right? So they're the owners of their own data domains. And this is something that is really just inherent to what platform development is all about. It's an important thing to understand in terms of microservices, and we'll come back to some of that later. And effectively, the idea here is that in a distributed system, in a platform that we're developing, each of the service components will effectively run in its own process and memory space. So it's effectively its own application, right? And the services are 100% responsible for managing their data domain, and that means the business logic. That means where the data gets stored. That means the data access objects. All of that kind of stuff is contained within these respective service implementations within the vertical, right? So that basically allows you to have built-in capabilities of scale. So again, going back to that idea that as the business evolves, the service implementations can evolve along with it. That means that these systems are designed to scale because they're the source of truth for whatever data it is that they're providing. And this kind of brings us to what we're actually building when we talk about building distributed systems and when we talk about platform architecture. We're actually creating a platform as a service offering. where the whole thing is comprised of vertically sliced business functions, and that means that we can draw meaningful boundaries at the service layer. This gives services purpose in the context of the business, right? So effectively, I think it kind of keeps things more guided for you as a developer. It's really easy as developers to say, oh yeah, I know that I can fit, function X into application Y. It's much better to say, I'm going to put it here because I know that it's satisfying a business need, right? And by thinking about it in these terms, by thinking about it in terms of developing a platform as a service, you're able to do that much better. It also means that when we have a distribution of services, the platform is composable, right? So that kind of opens the door for us, or at least for the business, to be able to compose the platform as is needed in ways that we don't even know about yet, right? So that's a pretty cool idea, that effectively things that the business might need in the future, we're already going to be able to accommodate, because we've built a distributed system. We can compose aspects in very different ways. So it means that ad hoc business needs are able to leverage the paths necessary to get at the data that they need to. And if you think about that insurance company example again, we said we have a vertical for underwriting, accounting, customer service, claims, but there's probably no need within the system for any kind of marketing capabilities, right? Marketing is something done totally externally, but if somebody on the marketing team, these are the guys out there selling the products for us, and maybe they are designing a new product, right? A new insurance offering or a bundle or something like that. And before they do that, they want some data, right? They want to know where they're going to be able to market it most appropriately. So they need to look at the data that the system is providing, so that they can understand where it's going to be most appropriate to market the new product. So typically, I think a BI tool would be able to make use of that, and in a traditional structure, there would probably be some shared database where we could get at that stuff. But in modern development, we can't be restrictive like that, right? We can't say that all the data is going to fit into a relational structure, for example. But we also shouldn't say that not all data is going to fit into a relational structure. So the idea that services are the source of truth for the data that they're providing also means that they can choose the right store, right? So when we're developing a platform as a service, we can with that distribution there, the marketing team can then basically take the components of the service that they care about and affix their own BI instrumentation on top of it, so that they can pull out the relevant data, process it accordingly. And that's something where, not in a distributed platform as a service, that might be a much more difficult task, right? And that kind of lands on a self-answering question at this point. Why is platform architecture important? And it's really for scalability, right? So that we can, but not scalability in terms of requests per second or in terms of computing load or processing load. It's not about that. It's about scaling with the business, right? And drawing those kind of meaningful boundaries to where the business functions exist within the system. So yeah, again, getting back to this, it enforces the modularity of concepts and not just code. It's easy to modularize code, or maybe it's not. I don't know. It's easy for me, but maybe not the modularity of concepts, right? Again, we kind of get back to this thing where as developers, we will eventually become very intimate with the systems and understand, hey, a new feature request has come in. Well, I could just kind of shoehorn it into this existing application or into this existing structure, and maybe that's not the right thing, right? So we really need to focus on the modularity of concepts, and that's kind of what platform development kind of gets us to, is true vertical slices within our architecture, and but that's the conceptual side of it, right? And the actual, once we have those verticals defined and we understand what those service boundaries are and stuff like that, we can get into the conversation of how do microservices fit? because this is the kind of the lowest level of the actual implementation, right? This is the structure by which we're going to satisfy developing out those business needs, right? So it's important, we have it sliced by business function, and then within each of those business functions, now we need to slice it down by technical requirement, right? So again, back to the insurance example, we have a risk engine, or we have some sort of actuarial engine, something like that. That can be a service in itself, but that probably shouldn't be tied together with the system by which the underwriters apply or approve endorsements to a policy, something like that. Those should be two very, very separate systems. And the purpose behind that is to make it so that the actual implementations are very focused, right? So it's easy, I think, to get confused between SOA and microservices. So SOA is just about being a service-oriented architecture, right? Being able to have services be separated from one another. And the value proposition, of course, in that is that those can evolve independently, and there's no hard coupling of the code within the system. Microservices are sort of a more refined definition of SOA in the sense that microservices should be designed to do just one thing and do it very well. And the purpose for that is so that you can very easily gain context, right? When you need to go in and apply a feature or fix something, you know when you jump into the code base that what you're going to be working on is one thing in particular, and additional functions of the system are not tainting the code base, right? So in the case of like the underwriting rules engine or the underwriting risk engine, we know very, very much what that's going to do. We would not go to that system, for example, to change some aspect of applying endorsements, because we would want to go to the endorsement microservice. And that allows us to kind of keep things very separate, which is great. And again, these are the low-level technical implementations of that system-level functionality. Together, many microservices expose the technical implementation of a mid-tier slice, right? So you can have many microservices that comprise a single business function, and all of those things colluding with each other will get you that functionality that you're looking for, that sort of overarching functionality. This also kind of lets you get to a place where when you're adding new features, you know that you're not going to be messing up some existing code base, right? You're going to be implementing something brand new. And that's kind of a cool thing for a couple of reasons. Number one is that we're not going to add cruft where it doesn't need to happen, right? So microservice architecture is excellent for that. Number two is that it lets us, it kind of releases the chains that we have today of relying on technology that's been established within an application, right? So when we're adding a new feature to a platform, to the overarching idea of the system, it's greenfield, right? So we can do whatever we want. You can use Spring Boot, you can use Grails, right? You can use whatever you want that's right for the job. And I think more importantly than that is that more important with respect to microservices than everything that I've just said is this idea that no two microservices are created equally, right? Two different microservices can have two very different processing and computation requirements. So when you actually get into it, going back to the insurance example, probably the risk analysis engine is going to have very different computation requirements than something that's just applying endorsements to a policy, right? So they can, since they're running in their own process and since they're running in their own memory space, you can have the right amount of computation for the particular service, right? And you can do this with physical servers, or if you're running in the cloud, you can spool up an instance with different computation resources allocated to it that'll make the job better for each of those. This will give you a better utilization of your technology footprint, right? So in a monolithic application where all the services are composed, you're basically hostage to the most computation-heavy part of that system, right? Even when you're building modular monoliths, you're still having to have a technical footprint that's relevant to the most computation-intensive service in your application. And that's kind of ridiculous, right? That shouldn't be the case. It's much better to allocate the resources that are appropriate for the job that's being done. And microservice architecture buys that for us. And when we're talking about developing a platform, this is kind of of paramount importance because as the needs of the business evolve and as they grow, we don't want to be spending a ton of money, right, on computation resources that are just perfectly unnecessary. So that's a cool idea. Actually, on InfoQ, Chris Richards, who's a Cloud Foundry guy, did a really great article. I think it was titled "Decomposing Services and Microservice Architecture," something to that effect. But he does a really great job explaining why in modern architecture it's important that we have these slices, these technical slices, so that we can appropriately manage our footprint at the cloud. So why choose Groovy, right? That's kind of what we're here to talk about. The platform is all about the service tier, and I think that I know that there's a misconception. Right now I'm probably preaching to the choir, but I know that there's a misconception that exists in this world that Groovy is not suitable for the service tier, possibly because people believe that it's not able to process as fast as Java or as fast as they need. So we'll kind of discuss how Groovy really fits into this high performance area of the system, and what improvements have come and what improvements are going to come that are going to make it a very suitable language for accomplishing this stuff. How many people here were at the Birds of a Feather, the Groovy Birds of a Feather last night? Just three of us. Okay, so Scott Hickey from Object Partners, he talked a lot about getting Groovy adoption at Mutual of Omaha, and that's pretty insightful stuff. I don't think it was recorded, but I think that Scott does a talk on that you guys can actually look up. He has a unique perspective and a unique insight of getting a very conservative company to adopt something that even at the time they believed was not suitable for their needs. So that's kind of a cool thing. The real answer here is that Groovy has really come a long way. Things are much different today than they were 5 years ago or 10 years ago. And I think that some of those early misconceptions about Groovy have kind of percolated through the ages, through the years here, and they're just no longer relevant. And a big part of this is that since Groovy 2, we've had the ability to statically compile code, right? So we can take Groovy code that is dynamic in nature and apply static compilation to it so that it compiles down into Java bytecode that makes it very performant. Also, since Groovy 2.0, we've had advanced type checking capabilities that basically can inform the compiler as to what your intention is, and in addition to that, can be leveraged by Groovy as a framework. So here's another aspect of Groovy that maybe is not very well understood. Groovy is a programming language. Yes, it has a syntax. Yes, it's very rich and easy to use, and it brings functional programming, blah blah blah, all the great sales pitches. But probably what a lot of people don't understand is that Groovy is also a pretty powerful platform for software development, framework for software development, because it exposes the ability to do these kinds of things, right? To change the way that the code that you wrote actually gets generated into JVM bytecode. And we'll talk about how we can kind of leverage its framework aspects for a lot of the stuff that we're doing. Also, Groovy's indie support Java 7 brought the invoke dynamic instruction to the JVM bytecode, which essentially was designed for dynamic languages like Groovy to be able to say, I need to, or I want to invoke a method that is going to be handled by some other mechanism by determining where that method invocation is actually going to go. Lambdas in Java 8 use invoke dynamic. It's a very powerful concept is very far along. It's being made to be extremely performant. So that was introduced in Java 7. It's getting better with Java 8. It'll get even better in Java 9. But Groovy has a classifier for one of its artifacts for invoke dynamic support, Groovy Indie, and we can get damn near static compilation performance and still maintain the dynamic nature. So still garner all the benefits that Groovy has as a language. When we do static compilation, we sacrifice a little bit, which is very sad. But we lose some of its dynamic nature because we've decided we just want to leverage the sugar. We don't want to leverage any of the meta object stuff that goes into it. With Indie support, we can leverage all the great stuff, and we can still get near static compilation performance. This is basically the only way to run Groovy nowadays, in my opinion. So consider that going forward. Even more than that, as if this weren't enough, even more than that, Groovy has this really awesome built-in capability to pick and choose your compilation strategy. So being able to say that I want parts of a class to be statically compiled, but then I know that there's this one method in particular that I want to be able to use all the great stuff that Groovy offers. I want to be able to use the meta object protocol and stuff like that. You can tell the static compilation engine to skip a particular method, right? So you can get that far down. You can choose one class can be statically compiled, another can be non-statically compiled. And that's a really, really cool thing. That's something that other languages don't really have that kind of support for it. So at the service tier, it's very important in some cases that we have static compilation so that we can reach those performance goals that we're really looking for. But then in our actual implementations, there might be parts of that we know are not going to be in the critical path of some request, right? But so we want to be able to still use the dynamic capabilities of the language because we like them, we know them, we like them, right? So Groovy lets us pick and choose that. It's not, you don't have to totally opt in if you need to use static compilation if you're not using Indie, or even if you are. But an important note on Indie, building a project with Grails, this doesn't come for free. So this, I think, will be important as Grails 3 moves forwards. How many Grails developers in the room? Okay, a dozen or so. How about just standalone Groovy in a web application? Okay, or it doesn't have to be in a web application. Okay, okay. And Java developers, just straight Java? Masochist. But as Grails moves forward into using Gradle and leveraging Gradle more heavily, this is just an important thing to note today, I think, more than anything. A really super smart dude that works at Netflix, not me, not me, Rob Fletcher. I have a link down here to his blog post. He actually, this is his blog post. So he actually figured out that when you, even if you're using Indie and Gradle, when you actually go to compile it, you may be thinking that you're using invoke dynamic, but Gradle has actually not turned on the optimizations for it. So you need to actually go out of your way to do that. So that's the kind of cool stuff you learn at conferences. Again, why would we choose Groovy? This is very kind of an important aspect, I think, is that maybe one of the most notable features of the language is that Groovy beans are much more superior to Java beans in every way. If nothing else, basically, I think if nothing else, it just kind of gets you to a point where when you're modeling data, so in a microservice architecture, we're encapsulating some data effectively. We're running that through business logic, and then we're serving that back to the client. That needs to be the flow in a microservice architecture. And that business logic component, of course, is the most important, but it all starts at the modeling of the data. And we model that data in Groovy and Java by using beans. Now, Groovy beans let us get at what the what the model is intending to represent without all the other noise, right? So it's easy for us to get a handle on what the data is very quickly without having to worry about getters and setters. So the verbosity is much lower. And then in addition to that, because of Groovy's meta object protocol and the ability to change the functionality of classes and to change its behavior dynamically and outside of a class, we have the capability to more or less enrich those classes, to build rich domain models out of beans that are modeled anemically, right? So we can add those domain-driven design capabilities, the rich model capabilities to Groovy beans through the meta object protocol in Groovy, and garner a lot of the benefits of rich models, while still, when we're looking at the beans at the end of the day, we're just looking at how that data is modeled, right? So we can leverage those capabilities that Groovy exposes for us. So that's cool. I think to understand that, consider it like a Grails domain class. And in a Grails domain class, we are literally modeling data that is going to a database, some persistence store. And to us, when we see it, we're seeing strings and integers and parameters and stuff that we would expect to represent the columns of the data, right? So that we're very quickly we can get at what is this domain class representing, and that's an easy thing to do. But then behind the scenes, what Grails does is it enriches those domain classes so that you have the dynamic finders, and so that you have the ability to save directly off of the Groovy bean. These are capabilities that are only possible with Groovy beans, and are a really good value add to your architecture, to your microservices, right? So that's a really good approach. Groovy actually has for years really great support for microservices just right out of the box. And this is probably something that maybe a lot of people don't know or recognize. Groovy SQL, which is the language's wrapper around making calls to SQL databases. It's a great foundation for data encapsulation, right? So if you are saving to a relational database or any persistent store that you can get to through JDBC, Groovy SQL is a really great choice for getting at that data, for getting a handle on that data. And Groovy's ability for string and basically for translating strings into URLs makes making REST calls to other services and to external services a breeze, right? So we can take a string, a URL, wrap it in a string, and instruct Groovy to turn that into a URL. And then with Groovy's stream modifications, we can just tell it that we want to get the text off of that, and that will actually go out, make the HTTP call, pull down that data, and then we get back the response in another string that we can translate from JSON into a map or whatever we want to do with it. So this is a really cool capability. Let's demonstrate some of this stuff. Oh yeah, and proven fact, Groovy has the world's fastest JSON parser. So JSON Slurper was put up against JSON and Jackson and all this stuff. There are some measurements that have clocked it at up to 5 times faster than Jackson, and Jackson's pretty damn fast. So that's pretty cool. When we're probably the most common exchange that we'll have between microservices will be JSON, right? So when we're consuming that data, we can get at it very easily. So so this is a talk that I designed for GreatConf in Minneapolis. So I already have the code for this published. It's on my GitHub right now. And what I've done with this is I've taken and broken it down into a set of commits, and these commits represent the different demos that I'm giving. So if you guys want to follow along, you can pull it up in GitHub and see. So check out the first commit here. And let's take a look at oops, I'm actually going to check out the second commit, sorry. Because what I want to show you guys here is, I want to show you guys Groovy's really great SQL support. And I have that in a file called Groovy SQL rocks.groovy, appropriately. Whoops. So this is kind of what this looks like. And basically what we're doing here is we're setting up the parameters that we're going to establish. Can everyone see that okay? Let me actually do this. I'm going to open this in the Groovy console so we can actually go ahead and run this. So what we're doing here is we're setting up the inputs for establishing a database connection, and then Groovy SQL has a we can tell it that we want to create a new instance of that based off of the details that we've supplied previously. And then what we can do is we can just send this sort of arbitrary execution off to the database to go ahead and do something that we know that we want to do. So in this example, what I'm doing is I'm creating a table called project. I'm putting an ID on it, and I'm adding some value of text, right? And then I'm just going to bootstrap a little bit of data using this syntax. Oops. Using this syntax where I'm parameterizing the inputs. So I'm inserting some values in, and then as part of the execution call, we can supply a map that corresponds to those named values. And this is a really cool thing to be able to do, because what Groovy will actually do behind the scenes for us is create a prepared statement. And we don't need to worry about SQL injection attacks, right? We're not wrapping this ourselves. Groovy will actually do that work under the covers for us. So this is the only way to directly interact with databases. If you're not going through an ORM, or if you're not using GORM or something like that, and you just need to make direct calls, and you have Groovy at your disposal, please do this. You'll save yourself a lot of headaches. And then when we're ready to get that data back out, we can just tell it that we want to select the rows for based off of this call, which will return us basically a collection of the details that are there. If we run this, you can see, of course, we got back a map of data, and it was the exact data that we had bootstrapped, right? So this is a pretty cool approach to getting at that data directly. And if you're in a microservice application, right, and you're encapsulating data, ORMs are really great, and ORMs are a lot of fun to use, but man, what a nightmare some of them can be, right? GORM makes things a lot easier for us, but GORM is heavy. It's very heavy. So it might be more practical for you to just say, look, I know how to write the SQL statements, right? And I know what these very specific operations are that I'm going to run against the database. And if you're going to do that, you can use this mechanism for getting at it. And that's a cool approach to interacting with databases. Now, another aspect of this was performing REST calls, right? And I'll show you that. Okay, so what I'm doing here, this is only semi-important, not terribly important, but Ratpack has test fixtures for embedding an application, right? So in this example, I'm just standing up a basic HTTP server with a single handler on GET, and what I'm going to do is just render some JSON out of this, right? And so let's say this is the remote server. We can basically ignore this part. I'm using Ratpack because Ratpack is the best web framework available, and it's really easy to do this kind of stuff. So, in full disclosure, I'm part of the core team, but it still is great, yeah. And what I'm doing here is I'm able to get a handle on the address very easily, and then I'm just taking it. So this address is really just an HTTP string. I'm translating that into a URL, And then in Groovy, when you have a URL, you can just say .text, and it'll do all of the work behind the scenes to perform that call for you, and out of that we'll get the JSON, right? And then we can use the JSON slurper, again, the world's fastest JSON parser, to turn that into a map for us, and we can make some assertions about that data. So if we run this here, I'm just going to print this out so that you guys can see it when we run it, that I'm not lying to you. And you can see, voila, our assertions completed. It would have thrown an error if those assertions hadn't worked, and you can see the data getting returned out of that. So this is pretty cool, right? And when we are a microservice, if we need to interface with external systems, Groovy already has the capabilities built into it for doing that. And again, not again. I noticed that happened to me yesterday too. So again, Groovy as a language is super cool, but Groovy is so much more than just a language. It has this vast framework that allows you to basically have injection points where you can influence compilation, and you can influence the way that the Groovy compiler is interacting with your code and the code that gets generated out of it. So a big part of this is Groovy's extension framework, and it allows you to perform compile time analysis, and you can kind of drive that around business rules, right? So it doesn't just have to be technical stuff. In addition to that, it can be business stuff, right? That you care about, that to ensure that you're doing the right stuff, and have the compiler tell you, it looks like, based off of the rules that you've provided me, that you haven't done the right things that you were intending to do. So I'm going to stop you. I'm not going to let your project build at all. That's a cool idea. In addition to that, it's easy in microservices, and I think that everybody here probably has seen at least one Spring Boot talk, maybe. Show of hands, who's seen a Spring Boot talk here? Yeah, so everyone has, right? It's easy in Spring to get annotation carried away, and especially if you are using some other framework like DropWizard. DropWizard annotations can get unwieldy at some point. Groovy's extension, Groovy as a framework has capabilities for rolling up annotations, so you can collect them into a single annotation, and that's called annotation collectors. Kyle Boone, whose place of work I can't remember, but doesn't matter. Guy in the Groovy community has, not that, this. He's written a very, very nice and totally pertinent article, blog post, using meta annotations to dry your Groovy. And Kyle's experience is working with DropWizard very heavily. And he talks about being able to take a resource that normally would have 5, 6, 7, 8 annotations on it, and compile that down into a single resource that they're able to use. This is only possible because of Groovy. So this is a really cool thing, right? That you can simplify your code quite a bit by doing that. And I will show you guys with, yeah. So I'll show you guys how we might go about So I actually have a Gradle project inside of the inside of that repository. There's a directory called Groovy Extensions. That's the Gradle project. You can open it in IntelliJ and get all the support, right? So what I've done, sorry, that is actually not the one I wanted to check out. I wanted to check this out. So what I have in here is a class, just a runnable class, right? And it's exactly what we've just seen. What I've done though is I've messed up, right? we want to say select star from project and not FRM. So I've written a bad SQL statement. We would never know about this until runtime, right? Because it's just a string that's getting executed. But we can be really smart with Groovy because Groovy, as a framework, allows us to have influence at compile time. We can write some rules around checking this kind of stuff. And we can do that through the type checked annotation and tell it that we have an extension on the class path at compilation time that we can look at that will be able to inspect the, I believe it's the abstract syntax tree. Yeah, and there's a DSL for this. But we'll be able to inspect those calls, those SQL calls that we're making, and ensure that we've done them right? So this is kind of a technical thing. So this is not code that I've written. Andre Steingress wrote this code, and he also wrote an excellent blog post on being able to do this. So I'd encourage you to check that out. But basically, what we can see is now instead of this running and us finding out at runtime that hey, something has gone horribly wrong. Yes, okay. What we get now is the Groovy compiler will come to us and it'll say, hey, it looks like you've done something wrong. See, there we go. Oh, sorry, not that. Yeah, so this is kind of something weird that happens with IntelliJ every now and again. It forgets about my resources. Bear with me. Here we go. Oh man, don't do this now. Okay, Gradle W build. Okay, so it doesn't think it's there either. Let me see. I will try one more thing and then we'll move on. Try that again. Yeah, okay, anyway. So this is, I'm not exactly sure why this is failing on me now, but I guess you can take my word for it that this will throw a compilation error and will tell us that, hey, we actually meant to say from. We said FRM instead, and all of the rules around that are designed inside of this extension class, right? That provided you can set up your projects like a grown-up and get them right, will actually work for you, right? And again, there's this very nice DSL that extension, the type checking extension framework is able to make use of. If we go to here where we've fixed it, then what we'll see once we fix it is that, again, if the class path resources came up, what we would see is that it's now working, right? So it'll stop your compilation. When you fix it, it'll bring you back to good. So that's a pretty cool thing, right? And the example that we're showing is kind of contrived. That might not be something that's a very big deal, and it's a definite technical one. But we can kind of use that mechanism to drive the way that the business functions need to interact with things that we wouldn't get any kind of compilation help from, right? So the world is your oyster with this and with Groovy. It has the door open. All that you have to do is build the right hooks into it. It's very cool. So going back to that idea that Groovy might not be good for the service tier because it's not as performant, this is an arcane argument. You know, this is something from years and years ago. Modern Groovy like I said earlier, things have changed a lot in recent years. In the last year and a half or so, Groovy is now extremely performant, and especially with Indy support, and especially with static compilation. Groovy is a really great choice. And there's a whole host of other things too that help the compiler get at the right details, so that there's not there's a limited amount of effort from Groovy to understand what you meant to say when you performed a method call, right? And the team, the Groovy core team, has done a phenomenal job getting the performance up to snuff and making it a really competitive programming language. So I recently ran some tests. Again, Ratpack, the best framework in the world. We are also very concerned about performance, and we want it to be a web framework that is able to have as much throughput as is totally possible, right? And so to facilitate that, so we have very different requirements in the performance area, and to facilitate that, and because we're a framework, the core of Ratpack is written in Java, written in Java 7. So, but we designed the core so that we would have very good Groovy integration. So you can affix a Groovy DSL on top of it, which is something that we've done. You can write all your applications in Groovy. The actual framework is not going to cause you any performance loss. But I wanted to see what is going to be the cost of using Groovy at the application level, doing something more than just a simple hello world. So I ran some tests against Java 8, which is extremely performant, against statically compiled Groovy, against Groovy with invoke dynamic support, and finally against dynamic Groovy. And I ran these on EC2, AWS EC2 on an M4 2x large for anyone that cares. The performance metrics were gathered using WSPerfLab, which is a Netflix Skunkworks project. I have a link in the bottom corner to that. And what I found is using Java 8, statically compiled Groovy, and Indy Groovy, Groovy with invoke dynamic, we were able to achieve a throughput of 52,000 requests per second, which is pretty good for a framework. And finally, I ran it with dynamic Groovy, and again, all of this was designed just to see what the cost was and what was going to be our preferred recommendation for using Groovy in Ratpack projects. And dynamic Groovy these days is actually still pretty good. We got 50,000 requests per second throughput, but as you can see here, this graph is not terribly compelling. Java, statically compiled Groovy, and Indy, they all scored the same. There's no difference here. It's only when we fall back to dynamic Groovy where we have the cost of jumping around and grabbing different call sites for different reasons, right? So the language and the framework of the language slows us down a little bit. And maybe in practice, that 2,000 requests per second actually costs you some business. So our preferred recommendation, as I said earlier, is to use invoke dynamic. So Groovy Indy is a preferred way. This is the argument for why you should use Groovy at the service tier. The argument against using Groovy at the service tier, based strictly on it not being performant enough, this is a non-argument, and I would encourage you to tweet me anybody that says otherwise, because we have hard facts around this thing, right? This is not guesswork at this point.
Have you ever run this benchmark with Grails web app doing the same functionality? Compare the framework overhead?
Sure. So I haven't, but Tech and Power has, and Grails gets a throughput of about 5,000 requests per second. At maximum speeds, which is effectively because of the container, Tomcat, or Jetty, servlet API, and request per or thread per request. This is a very slow model of doing things. So Ratpack is built on Netty. It's a non-blocking asynchronous framework, and that's how we're able to achieve these super high speeds.
You know, it's similar to like Hello World web app.
It's actually so. Hello World is not a great way to do benchmarking. So all of these are basically doing simple service calls. So in a Hello World application, they all of these permutations scored the same. And that's because at some point Groovy has cached call sites, and it doesn't need to reach out to the mop to do anything. So we need to actually build in a service tier into the application to make it go off and do that stuff. And only then is when we can actually sort of measure the differences there. So when Tech and Power does it, it's something to that effect. Yeah. So that kind of brings it to this point of what are some of the tools that we can leverage in the Groovy ecosystem for designing platforms, right? So we've talked a lot about the approaches that we can take to microservice architecture and to understand the needs of the business, right? These are the takeaways. Those are the takeaways that you should get from this talk, and also the takeaway that Groovy is very much the right language for accomplishing this goal. But let's talk about how we can actually get there, right? Here's a great one, and one that has a extremely bright future. So Grails, of course. Did anybody else here go to Graham's talk on Grails 3 yesterday? Or maybe it was the day before? Yeah, yesterday. Okay, so a couple of people. So Grails 2 is probably not a great choice for microservices. I feel very comfortable saying that. There are some talks here at this conference going on about using Grails 2 in a microservice capacity. I think that there are much better tools out there. I wouldn't recommend using Grails 2 for a microservice. That said, Jeff Beck is doing a talk on it. He's around at the conference. If you guys want, I know that he's really happy to talk about his experiences at Reach Local, where they've built a microservice architecture on top of Grails 2. But I would say the future for microservices and Grails is going to be in Grails 3. And that's because Grails 3 will be built on Spring Boot. And it'll introduce this idea of application profiles. So Grails 3, the Grails core team has gone to a lot of work to decouple Grails from the servlet API. And that gives them the capability to run outside of the container and basically to run on anything that's able to get them HTTP requests, including Ratpack, which they're going to do. So Grails will be able to achieve those super high throughputs as well, and still be using Grails fixtures within the project, so Grails structure. Grails also ships with Gorm, and Gorm is, if you're not going to write SQL statements, if you don't know exactly what your SQL statements are going to be in advance, and you need something that is beyond a select star from table approach, Gorm is the only ORM, in my opinion, anymore. Anybody who's ever worked with Hibernate knows what I'm talking about. The pain of ORMs is excruciating. Grails makes this much easier for us with Gorm. So that's a project that's very far along. It's standalone and available today. In a standalone fashion, you can run Gorm directly inside of Spring Boot. We'll talk about Spring Boot in a minute. But in addition to that, better than any framework that I've seen, Grails has extremely advanced REST support. So Grails is still very much a contender in the microservice world because of the fact that it's come so far along with respect to its REST support. It's just phenomenal. Being able to map resources seamlessly based off of a domain class that you're working with in Gorm, and being able to define renderers at a different phase in the process. That's pretty huge. Some of that work that was done in there, we've taken inspiration of it for it in Ratpack, and adopted it. So that should go to say that Grails, as a 10-year-old framework, knows what the hell they're doing with respect to HTTP and all this stuff that we're talking about. But I would say in Grails 3, this is where we want to begin adopting Grails in a microservice capacity. Spring Boot, we've all heard about. We've seen the demos at the keynote. Spring Boot is an opinionated framework. It takes all of the work of setting up a contained microservice out of the equation and just lets you focus on writing the code for your for whatever vertical slice that you're looking to implement, right? Boot also, because it's built on top of Spring, also comes with advanced REST support. So during Andy Glover's keynote, he said the JVM's been around for 18 years and Spring has been around for, what, 15 of those years or something? So Spring knows how to talk to the web as well. They get it, right? And as part of that, they have this extremely advanced REST support and ability for rendering data, maybe not as good as Grails, but it's still very strong and powerful in there. In addition to that, so the guys at Pivotal who were working on the Spring framework, they picked up that microservices were going to be a thing, right? And they started down this path of developing Boot. And one of the things that they wanted to ensure was that Boot would be a platform for microservices, right? Boot would be the framework for microservices. So they built a lot of production-ready libraries into Boot. And you can just pull those in as part of your projects and get a lot of microservice capabilities like health checks and metrics and the ability to see configuration properties and stuff like that just by pulling in a library. That's pretty cool. And they also recognize that it needs to be a cloud native thing, right? So that you can take a project. I'm not going to demo. Everybody saw Dave Sire talk at the keynote about this, yes? Show of hands if you did not. Okay, I'll show it for you later. But basically, Spring Boot is able to tool the build system in a way that allows it to package a fat jar that you can ship off to Heroku or I guess for these guys, Cloud Foundry, and be able to run it there, right? So the footprint is very small for working with Boot applications, and as I would say, probably a better argument for not using Grails versus what I said more than anything is just that when you package a Grails application into a WAR file or into using a standalone plugin into a jar file, the artifact is huge, right? It's potentially 100 megs, potentially several hundred megs, depending on plugins that you're using or anything like that. This is unacceptable for deployments. You know, you want a very small artifact that you can ship to a server and will get started up very quickly. That's not what Grails 2x is designed for. 3x will be designed for that, and that's a pretty cool thing. And that's because they're building on a lot of this work of Spring Boot. The stuff that those guys have done is going to be at the core of what Grails is able to do. So when you build a Boot application, you get artifacts that are in the tens of megabytes, right? And they start in seconds, not minutes, you know, or tens of seconds on probably a better scale. Kind of an important thing to point out, I think, is at Netflix, the team that I'm on, we are in the process of doing this, building a platform as a service. And we had previously been working with Grails applications. And one of our more popular open source projects, Asgard, is a Grails application. Has a lot of contributions from the community. It's a very, very, very engaged thing. We've made the decision to move away from Grails because it was not going to fit our needs in a microservice capacity. Even though I'm a core developer on Ratpack, we still decided that we wanted to go with Spring Boot because Spring Boot is so far along. They've made a lot of the right choices for accommodating microservices. So everything that I've talked about here is stuff that we're doing in practice, and we're doing it with Boot. To me, there's not a better reason not to do that, right? And Boot is great because we can just throw Groovy right on top of it. We can write our entire application in Groovy. We can use all this cool stuff that we talked about, and then just have Boot power that microservice and get the ability to package fat jars and to have those super small deployables. That's pretty cool. Now, it shouldn't go without mentioning that Ratpack is the best framework in the world. I don't know if I've gotten there.
what that is?
Yeah, sure. What slide did you see that in? Sorry.
It's third bullet down on the slide, you just, right there.
Oh, yeah, yeah. Yeah, sure. So the advanced REST support and edge slicing. So I'm not sure this is a real term. This is just something that I've said. But what we're talking about here is the edge of your application, right? Being able to so you don't need to have all of your application defined within one controller or within one web XML or something like that, right? That's the scary part of servlet programming, is having a server XML or a web XML where you're defining all your servlets, right? Spring Boot, because of Spring, we can build resource-oriented APIs where we're effectively taking the edge of our application, we're slicing it across many classes or potentially many modules. Something that we're particularly keen on doing is having multiple modules represent different concepts that the microservice itself is servicing. So this is kind of a weird modularity story, but anyway, when we get into developing microservices, they're satisfying one technical requirement within a vertical of a business function, but then within those within that particular microservice, it may have different facets to solving that particular problem. And to accommodate that, we build them as multi-module projects. So these are somebody. I was explaining this to Peter Ledbrick yesterday, and he said, "What did he say? Micro monoliths or modular micro monoliths is probably the right term for that." But the idea there is that the edge of our application, the injection point into working with a managed resource that we're exposing a REST API for. We're able to slice that across different modules, different classes, all that kind of stuff. We don't need to have that defined up front. Just by us putting a module onto the class path with boot, we're able to component scan it into the application context, and it'll map all those routes for us. So that's kind of what we're talking about here. And that's a good question. Thank you for asking that. That kind of makes composing the routes and composing the APIs that we're exposing much easier, right? And a lot of that is enabled just because of Spring's capabilities. And it's a limitation. Well, I wouldn't say it's a limitation. Ratpack and Boot have very different goals. Like I said, a lot of that is accomplished by Spring being able to component scan and map those routes automatically for us. Within Ratpack, you don't have the capability to slice the edge of your application. You do have the capability to programmatically manipulate it, so make some assertions about the way that a request should be handled and routed to different handlers. But in effect, that's a great value that Spring Boot provides. Ratpack in the Groovy ecosystem, Ratpack is a really great choice for service-tiered applications that need to be extremely performant. So going back to that idea that we are in a monolithic application, in a non-microservice architecture within the platform, we're sort of hostage to the worst performer. In a microservice architecture, we're not, right? We can have the different microservices act for whatever their performance needs are. And in the case of Spring Boot, for example, your application will be packaged into an embedded Tomcat container, right? And more or less, if you're just using it right out of the gates. And that follows that request per thread model. But maybe you have a service in particular that needs really, really super fast processing and high throughput. That's where you could use something like Ratpack. And Ratpack has a great DSL for Groovy. It also has seamless static compilation, so we can actually take your Ratpack.groovy script that defines your application and the edge of your application and statically compile it on your behalf if you tell it to do that. We also have really great integration with Groovy SQL. I gave a talk on Ratpack yesterday. I think that you guys will all have early access to those videos pretty soon, I think. So if you're more interested in Ratpack and the way that it works, you can look definitely at that talk, or you can ask me after that. After this, I mean. I will point you guys to one resource in particular that is very good, and that is in the GitHub organization Ratpack. We have an example project, and this is more or less a microservice. So this was built by one of our core guys, Russ, and this application basically showcases all of the features of Ratpack. And in particular, one of those things is a SQL module, right? So that stuff that we talked about getting at that data, he has an example of doing this very well. Book DB commands. And so he is using Groovy SQL. He uses it with Hystrix so that he has caching available. So we also have great integration with Netflix open source technologies in Ratpack. And he's able to run all these commands based solely around the Groovy SQL support. So that's pretty cool. This is a great resource if you're interested in Ratpack, and I would definitely encourage you to look at that. Now, from the standpoint of tooling the build system, that's one of the huge value propositions of Spring Boot, right? So you can just build the fat jar. That's your artifact. You can ship that off to a service, et cetera. Ratpack does the same thing for you. You can build a fat jar. I think the difference here, in addition to the performance of a running Ratpack application, is that you have application startup times that are sub-second, right? So it starts up basically immediately, depending on if you're doing nothing at startup, which you probably should be doing nothing at startup. But you can get a microservice application started in tens of milliseconds, not even seconds. So Ratpack is an excellent choice for building microservices, I would say. Vertex actually fits very well into everything that we've talked about. Is anyone here, has anyone used Vertex? Are you guys familiar with this? So Paul and Cedric, okay. Yeah, so Vertex is a web framework. It's an asynchronous, non-blocking web framework. Similar goals that Ratpack solves. Vertex fits very well into the ideas around developing a platform and developing a microservice architecture, because in Vertex you vertically slice parts of your application. So it has this kind of built-in these built-in constructs for taking the components of your application and building them into what it calls verticals. And that's everything that we've talked about. And if you understand this, then you can write Vertex applications very easily. Vertex has extremely high throughput, even faster than Ratpack, and that's a huge credit to it. It has polyglot support, support for Java and Scala and Clojure, and basically anything that can run on the JVM can run in a Vertex application. But as part of that, it has support for Groovy, which is really great, and that's the only language you should use anyway. And also, it too can be packaged into a fat jar and shipped off to a server. So you get that kind of small footprint for creating your applications, and it also starts up very quickly, et cetera, et cetera. You can Google Vertex for more details. It's a really great project. So these are I would say the frameworks that you should be looking at to get started with building out your microservice architecture. Yeah, question.
So you mentioned before, we're kind of looking at Dropwizard. Where does that fit into this?
That's a good point. So I didn't include Dropwizard because, well, quite frankly, I've never used Dropwizard. But I know enough about it based on our, we looked at Dropwizard as one of the potential uses at Netflix. And we didn't land on it because it's super opinionated about the way that you construct resource-oriented APIs. And a lot of that is driven through JAX-RS, but it doesn't give you any help in the areas of DI or anything like that. I think Dropwizard could be a good framework for developing microservices. It's probably just that I'm not experienced enough with it. But I think that you're probably better off going down the road of something like Spring Boot, which has much broader support for all the REST type stuff that you're trying to do. So in Dropwizard's world, a really kind of a nice thing from a framework perspective is to be able to say, okay, I'm only going to support JSON, which is great, right? And it makes the implementations in the framework very easy. Practically, that's probably the number one format that we'll be working with to transmit data. But there certainly could be requirements in your environment to serialize to XML or to have different ways to render the details back to the client. And I think the support for that for doing, for managing how you serialize objects back to clients is much better in Spring or in Grails, right? But yeah, it definitely is very, very popular in the microservice world on the JVM, so it's worth looking at. For Dropwizard? I don't, but I do know that Tech Empower has also done Dropwizard. I just don't know it off the top of my head. So Tech Empower periodically publishes these performance guides. Actually, in the last one, Vertex got taken out because they didn't write the application in the way that the framework maintainers wanted it written. So they asked to have it removed. But Vertex has throughput in the 90s of thousands of requests per second, which is pretty cool. So to summarize here, basically the idea behind microservices should be the idea that you're developing a broader system, right? You can't just write microservices that don't go together with something, right? That's not what microservice architecture is about. When you are developing microservices, you're developing this bigger system. And when you're developing that bigger system, those components of that system, the microservices that go into it, are what comprise this platform that makes it up, right? And the goal behind that is that you can scale as the business needs grow. So this thought that I think can be somewhat prevalent with people who have been developing systems for years, that a system should be defined by its limitations. This is no longer an argument, right? Because we can build very scalable systems in a smart way these days, and that's what microservice architecture has enabled us to do. And the idea of platform architecture is organizing those microservices into verticals that correspond to the business, right? And that's the important way to go about it. And of course, as you're doing this, the whole purpose of this talk is to sell you on the fact that you should be using Groovy to do this. And don't be nervous, right? Don't be scared. There's a ton of stuff in the Groovy ecosystem for getting going with microservices and with developing platforms. And you should leverage it. You shouldn't shy away from it. That's it. That's all I got. Any questions? Comments? Concerns? Yeah. So the question was, on GitHub, is there more or less, is there a canonical example of building microservices and structuring it? I don't know is the answer. What I can say is that the stuff that we're working on, that my team is working on at Netflix, will be open source. And that's, man, I think we're up to like 25 or 30 microservices right now. So we've kind of taken the idea of microservice architecture. So Netflix has always been known for SOA, right? Service-oriented architecture. We were, and even microservice architecture. We were one of the biggest and first companies to really announce that we had sort of adopted that as a philosophy for system architecture. We, on my team in particular, we've taken that idea to the extreme, and said we definitely want our microservices to only satisfy one particular thing. We want them to do one thing and do it very well. And that keeps the code base very simple, right? So when we jump in there, we're doing a lot of stuff. So we're doing continuous integration, continuous deployment, continuous delivery, all of this kind of stuff. There's a lot of concepts that go into that. And we want to be sure that when we're going to make a change or when we're going to update something, that we're only going to affect some aspect very specific to the functionality of the broader platform. And so we've broken everything down into microservices. It's a very clean separation of code. The code is extremely good. I wrote a lot of it. So it's not open source yet, but it will be. If you Google Netflix tech blog, you can follow the tech blog, and we'll certainly be announcing it on there soon, I hope.
So how do you manage all these microservices? Because it's so small and modern, you go and spread around. So how do you make sure that it's managed?
Sure. So the question was, how do you manage all these microservices? Once you get them together, how do you make sure that they don't get overwhelming, right? There's a bunch of different ways to do it. I think the stuff that Dave Sire showed in last night's keynote about Spring Cloud is the goals that they're solving with Spring Cloud are the ways that you manage a platform as a service, and that's through mechanisms like service discovery and registration, some sort of unified health checks on the platform. There are tools in the Netflix open source. So I keep coming back to this. The thing is, at Netflix, we've been doing this for a long time, right? And so we've built a lot of the tooling around this kind of stuff, and it's all open source. It's all available. So we have Eureka, which is a service discovery and registration. We have actually, I'm not sure if our health check system is open source, but we have a unified health check system at Netflix called Atlas, where all of our microservices publish metrics to it, and we do that. We can do that through Spring Boot by its integration with health indicators, and its integration with CodaHail metrics. So that's another good argument for Boot, I would say. But yeah, so we publish health off to that, and we can set up alerts and checks and all that kind of stuff. That's really the right way to do it, I think. Managing from an updating standpoint and a controlled deployment standpoint, this is the tooling that we're building at Netflix for being able to do this much easier. So today we use Asgard. We have another tool called Mimir, which handles the continuous delivery and deployment side of it. Asgard is our interface for managing all of our applications. We're taking that tooling, the things that we've learned from that tooling, and we're building a whole new platform as a service around those concepts. So we're dogfooding a lot with doing that. There are a lot of ways that are already out there for being able to manage that kind of stuff. Packer and Docker are really great solutions for that kind of stuff. Does that answer your question? Yeah, sure.
How is the performance in microservices? In-process call is much faster. Performance better than network.
Yep. So the question was, what's the performance implication of versus being within the same JVM? Yeah, there's overhead, right? There's definite overhead for performing the network call, performing the remote call. That costs you a little bit. You can be smart, I think, about the way that you do this kind of stuff. Oftentimes, I would say it doesn't matter that much because very few services are actually interacting with each other until you need some unified view of the data. In which case you would be making calls anyway. It's a cost that's worth it, I would say, as opposed to having a monolith where you're hostage to the worst part of your app. But you can be very smart, like I said, about the way that you do that. You can use HTTP streams instead of making a direct call, a request response, which comes with attacks. You can use caching strategies, etc. At the end of the day, though, the cost is going to be whatever call that you're making to your database, right? It's not going to be the HTTP request. Yeah.
Any insights on service versioning, dependency tracking, that sort of thing?
Yeah, definitely. I think that there are 50 or 100 talks on microservices that covered this, but the basic idea, I think, in modern development, HADOS, hypermedia as the engine of application state, effectively the answer to versioning your API. So the question was, how do you version your APIs in a microservice architecture? I think HADOS is the answer, HADOS, however you pronounce it, where you can actually affix a version to the specific content type. Grails has great support for versioning APIs with hypermedia. It's definitely worth looking at for that. But that's the only way that I would do it. APIs where you see a version embedded in the URL string, this is not a good way to do it. Definitely through hypermedia. Internally within Spring applications, it'll route totally appropriately for you. So that's the way I would do it. Did you have a question?
You didn't mention ReactiveX framework.
Sorry?
ReactiveX framework, do you know anything about that?
ReactiveX? No.
I thought that was in that.
I don't know. Do you mean RxNetty?
It was like RxJava and...
Yeah, so RxJava is a library. It's not a framework that just supports reactive extensions. The guys on Netflix platform team have taken RxJava and put it on top of Netty. And as part of that, they're building application structure similar to the way that Ratpack works. But they're doing it with extremely high throughput, 60, 70,000 requests per second. It's early days for that kind of stuff at Netflix, but certainly one day it would be a very good contender for microservices. Somebody else had a question? Yeah.
Along with this microservices architecture comes this, the idea of having a very lightweight runtime.
Yeah.
And a lot of corporate clients and whatnot have this idea of using these much more heavyweight application servers because they've got one throat to choke and all this sort of thing.
Yeah.
What would you say to a CIO or CTO that has this mentality?
I would probably outline. So the question was, in large enterprises, you're running WebSphere is basically what he's getting at. And so how do you in a large enterprise, how do you convince the CIO that we should move to microservices? I think all the arguments are outlined here. There's this separation of, so having a monolithic application, besides the fact that, again, you're hostage to the worst part of your application, means that every change that you make is going to introduce risk. You can mitigate a lot of that risk with very good testing, but there still is risk there, right? Any change that you make can break something. In a microservice architecture, because you have the technical implementations sliced out not only into their own projects, but into their actually only actually to their own deployables, and you're only composing those as a platform later, means that you have sort of a better boundary, I think. So the risk is much lower for affecting for some side effect to happen to something that was totally unrelated when you were making the change. Yeah, it's a definite culture shift. It's not going to be one overnight, not by any means, but I think that the compelling parts of microservices kind of outweigh the, we need to stick with something like a WebSphere or something like that. Yeah. Other questions? No? I think we're out of time. Thanks a lot, everybody. Appreciate it.